よし。それでは、では、本日も始めていこうと思います。そろそろ配信が始まる時間になりましたね。SpaceX さん、開始の時間になりましたね。では、の設定を自動にするんだこれ。じゃあ、これより見ていきましょう。SpaceX さんの配信を眺めましょう。本日はあと30分したら打ち上げ時間となってます。なので30分ぼちぼち付き合ってください。よし。私はとりあえずただ単に30分のんびりしてんのかな。眠い。始まったね。SpaceX さん、おはようございます。今日は打ち上げ頑張ってください。違うね、まだオープニングだね。ちょっとまだ時間があるようなんで、のんびりします。さあ、今日は岩手県の外れるでしょうか。スターシップを支えている、ホールドしている岩手県が作動するでしょうか。それだけです、今回は。前回はなんだかそのパワー関係でね、トラブルがあったもんで、うまくね、打ち上げられなかったけど、大丈夫だと信じてます。
Hello once again, Star People, and welcome back to Starbase Texas. It's currently 5:01 p.m. Central Time, and we are just 28 and a half minutes away from the first flight of SpaceX's next generation vehicle, Starship version 3. Yesterday's launch attempt was scrubbed due to a hydraulic pin on the pad tower that wouldn't retract. But good news, the teams were able to resolve that issue, and we're proceeding ahead with attempt number 2 and blue skies to boot. I'm Kate Tice, Senior Manager of Quality Systems Engineering.
And I'm Jake Berkowitz, a Lead Propulsion Engineer. And today we're coming to you live once again from just outside the production floor at Star Factory, where the team's preparing for Starship's 12th test flight.
Yeah, yesterday was certainly a nail biter as we recycled to the T-minus 40 second hold a couple of times. And while we unfortunately weren't able to lift off, keep in mind that this is the first flight of a completely redesigned vehicle. So we actually learned a lot in what became a wet dress rehearsal yesterday.
Yeah, that's right. And Starship version 3 has undergone significant upgrades, taking everything we've learned from the previous 11 flights to make the vehicle capable of full and rapid reusability.
We're debuting a new launch pad, new booster, new ship, and new engines, just to name a few.
Yeah, that's right. And as a member of the Raptor team, I can tell you we're all super excited to finally see the newest generation of Raptor engines, also V3, take flight today.
I love that view looking up under the Super Heavy. Now, Raptor and Starship version 3 are designed to enable us to send payloads and eventually people all the way to the moon and Mars.
Yeah, and in the meantime, we're planning to put Starship to work on future flights by launching bigger and more powerful Starlink version 3 satellites, which aim to substantially increase capacity in orbit, strengthen the network, and deliver an improved experience for customers.
Now, turning our attention back to today, our primary objective for Flight 12 is to put these new redesigns all together in a real, live flight environment. From the outside, a lot might look familiar on Starship, but beneath the surface, it's all new. As we've said before, Starship is still a developmental program. What we're doing today is a test. We launch to learn, and we test like we fly.
Yeah, and it's really the data we're expecting to get back from today's flight that will bring us closer to making Starship operational and unlocking the next generation of our future in space. So, no matter the outcome of today's test flight, excitement is guaranteed.
Now let's head a couple floors upstairs where Dan Hewitt is just outside our Launch Control Center. How's it going up there today, Dan?
It's going great, Kate. Everybody, welcome back for round 2. I'm Dan Hewitt with SpaceX Communications. We're looking good for a launch today. Do you want to do a quick summary, though, of what we saw yesterday, how we got back to launch? It's a really good example of all of the different moving parts that have to work together to get a rocket off the pad. About halfway up that tower, you see an arm that holds all of the propellant connections into the ship. It's also set up so it kind of pushes against the ship to help make sure that we have a really good connection, and it stays attached when we unlatch that quick disconnect. There's a pin in the arm near where that attaches to the tower that has to be removed before the arm can swing away for launch. It's important to remember there's a lot of benefit to not release the arm too early or too late, and a lot of hardware that has to work in concert in very, very short time frames. We started to unpin it. Releasing that tension caused some motion in the arm and triggered a hold, and that put the pin back in. Then that got us into a bit of a tug-of-war between systems on the tower that rely on hydraulic pressure to work. Really, the arm trying to keep its pressure on the ship and trying to pull that pin out. You saw we made a couple of attempts to fix the issue, eventually got the pin to start retracting again, hit the same motion hold, ultimately ran out of time. The team, though, made some hardware, some software changes to get us into a better position to fly today. We had the tower team up there last night. They rolled in some hardware that's going to cut down on the motion of the arm as it's pushing back and the pin's released. And getting all the data we saw on how this hardware interacts in those critical moments, went in, looked at our software, all of our logic, see where we were overly conservative, where we may have had holes readings at the right times. Overall, though, really fast work by the engineering teams put us in a position for flight today. Heroic work by our logistics teams to get all the propellant out there. But things are looking really good for launch at the moment. Right behind me, all of the flight controllers on console, looking at the rocket, looking at the pad, looking at the range, all the systems as we count down to liftoff. Propellant load is underway. You can see the rocket getting frosty. We're on track to launch at the top of our window at 5:30 p.m. Central Time. Weather has been gorgeous. Thank you you to everybody who was outside yelling at clouds that got us weather yesterday. It extended into today, and we are looking at a green range right now. Functionally, today's countdown, identical to yesterday. It looks very similar to previous Starship flight tests. Some minor differences in timing on things like when we start propellant load, when the water starts flowing on the diverter, when our engines start up. But all the hardware is new. New booster, new ship, new engines, new pad. Let's do another quick look at everything that's debuting today with Starship version 3. As Kate noted, some of the outside will look familiar, but we've made extensive upgrades across the entire system. Big picture, because Starship's still very, very big. It's just over 407 feet tall, fully stacked, a little bit taller than version 2, have more propellant impulse stages. On the bottom half, our super heavy booster has some visible structural changes on the outside. On its top, we've got an integrated hot stage now. We got rid of the one-time use one, so we're doing that for reusability. The ship's Raptor engines are going to be igniting directly into the top of the booster. That's where you're looking right now. All of that force and heat by the pressure inside the booster's fuel tank and a thin layer of non-structural steel. The grid pins on the booster, which we used to steer on descent, went from 4 down to 3, but we made them 50% larger. Higher strength, we'll also use them for lift, and we'll use them for catch on future missions when we bring the booster back. We redesigned the fuel transfer tube inside the booster. That's what's sending all of that massive amount of liquid methane down to those 33 engines. Lets us light all 33 at the same time and have faster, more reliable flips. The bottom of the booster looks very different with those Raptor 3 engines. Deleted all of the bulky engine shrouds from previous generations, all of the prop, avionics hardware, everything for that super tightly integrated now, protected by much slimmer shielding. Up on the second stage, Starship version 3 designed to carry massive orbital payloads up to 100 metric tons to Earth orbit, the Moon, and Mars. Biggest changes inside the vehicle itself. Propulsion system got a complete redesign, increased our propellant tank volume, improved our steering on orbit. In the payload bay, the PEZ dispenser supercharged. That's going to increase the deploy speed for each of our satellites. We've got 22 payload deployables in there today. It's the heaviest we've ever carried on Starship. Eventually, we'll have up to 60 planned of those Starlink V3 satellites. Also on the ship, we added docking ports. There's 2 right below the payload bay door, 2 near the bottom. That's going to enable us to have Starships link up in orbit for propellant transfer. Also modified the connection point in the ship to facilitate that. So a lot of upgrades. Tip to tail, and still powering it all is the Raptor 3. Now, those engines are manufactured in Hawthorne, California, tested in McGregor, Texas, redesigned their ignition system, bumped up the thrust in the sea level and the vacuum engines, and then took all of the sensors, feed lines, controllers, everything that was kind of the busy sections around Raptors 1 and 2, and either deleted them or internally integrated and protected them inside the engine. That dramatically cut down on the weight, made it easier for those to manufacture. So, just an incredible amount of effort from the world's best engineering team to get this rocket to the pad ready to launch today. I'm going to stop talking for a little bit. That was a lot. Send it back down to Kate and Jake for more on Pad 2.
Yeah, so like Dan was just saying, the team has been working hard on a brand new rocket, but we also redesigned the ground system, and that brand new Pad 2 is making its debut today.
We took everything we learned from operating on Pad 1 to create this totally new launch pad. Pad 2 is optimized for full and rapid reusability. We've upgraded our propellant farm with much more storage and more pumps to enable super fast filling for launch and relaunch. And on the tower, we changed to shorter chopsticks. That's the black assembly there at the top of the tower, and that enables even faster motion to better track vehicles flying in for catch.
Yeah, and we also changed the actuators driving those chopsticks from hydraulics to 100% electromechanical, increasing their speed, redundancy, and reliability. On the ground, the launch mount was also completely redesigned. If I had to describe it in one word, I'd say robust. But it's also smarter. We've separated the fuel and aux systems into different compartments and repositioned the booster quick disconnects to be out of the vehicle's plume during liftoff.
しわしおか徹夜が美徳とされる不思議な国ジャパンですので。
bidirectional flame diverter and a new top deck flame deflector to eliminate metal wearing down. So we say goodbye to the pancake. However, this will help us get to zero refurbishment between launches. This pad is still built for maximum safety and fast turnaround because making life multiplanetary will require launching a lot of starships. Now, it's currently T minus 18 minutes and 38 seconds. We're going to hop over to Hawthorne for a moment for more on Starlink with Tyler Lionquist. Tyler?
Hey, Kate, thank you so much. I'm Tyler Lionquist, and I'm a Starlink business analyst here at SpaceX. We're excited to be back here in Hawthorne, ready for another attempt at launch today. So, as we talked about yesterday, on today's flight, we're deploying 20 Starlink simulators, plus 2 modified Starlink satellites, which our team internally refers to as Dodger Dogs, because they stretch the V2 mini satellite propellant tank that sticks out from both ends of the satellite. And the Dodger Dog serves as a tech demo between the V2 and the V3 Starlink satellites, and acts as a platform for testing V3 components. Now, the larger V3 satellites aim to greatly expand our network's capacity, while V3 hardware is designed to support faster Wi-Fi and improved broadband speeds for our customers while providing significant capacity upgrades from the V2 Mini. So, in addition to delivering future V3 satellites to Starlink network, Starship is also planned to launch our AI satellites. And as you may have seen during the TerraFab event in Austin a few months ago, Elon laid out a path to revolutionize cloud computing and AI infrastructure, leveraging the limited power of the sun, targeting 100 gigawatts to 1 terawatt of AI computing power annually. And from there, we're looking at connectivity beyond our planet too. Building on the technologies used to connect people on Earth, the Starlink team is exploring using Starlink to provide high-bandwidth connectivity around the moon. With a constellation of satellites designed to connect to user terminals on the lunar surface, we could relay data back to the Starlink constellation in Earth orbit. So traditionally, deep space comms have relied on radio frequency transmission. But this new design would use lasers to relay data back to Earth, which would massively increase the bandwidth available to future lunar missions. We currently have thousands of lasers operating in our Starlink constellation around Earth, and deploying that technology around the moon could connect it to hundreds of terabits of capacity. Together, this would provide a connectivity backbone between Earth and the moon, and enable gigabit connectivity anywhere on the lunar surface, providing data for rovers, habitats, and astronauts, and hopefully some incredible views for us back on Earth too. So all of that adds up to a lot of satellites. But the good news is there's still plenty of space. That said, the Starlink team takes space extremely seriously. We work hard to encourage best practices across the entire industry so space stays open for as many people as possible. Just yesterday, the Starlink team launched a on Starlink.com to encourage all satellite operators to better coordinate and follow best practices to keep space safe. So for more on safety, go to starlink.com/updates. Let's kick it back over to Kate and Jake and Starbase for today's mission profile.
Thanks, Tyler. Now let's dive into the flight profile for today's test. As we mentioned already a couple of times, there are numerous redesigns making their debut today across the entire launch vehicle. In light of this, we want to keep our learning focused on all of that new hardware and software. So we're running a flight profile that's similar to past Starship flights in order to minimize any new variables.
Yeah, that's right. So as always, we start with liftoff, where Super Heavy ignites 33 of those brand new Raptor 3 engines and power through Ascent ahead of hot stage separation, where the booster shuts down all but 5 sustainer engines. Stage 2 then lights the Raptor engines while still attached to Super Heavy, where we see stage separation, debuting the integrated hot stage, directional booster flip, and engine relight with boost back using 33 engines. And after coasting for a few minutes, the booster today will target a landing burn and soft splashdown a few miles off from the coast of Starbase.
The ship keeps it going with Ascent burn to a suborbital trajectory. Then we'll deploy 20 Starlink simulator satellites and 2 Dodger Dogs, as we affectionately call them. We also plan to relight a single Raptor. Next will be re-entry a few minutes later. For the first time in a while, we're intentionally not messing with Starship's shield. At that point, we should have some amazing views of the ship's Technicolor re-entry through Earth's atmosphere. If all that goes as planned, we'll finish the test with a landing flip, a landing burn, and a soft water splashdown in the Indian Ocean. And in just a few moments,
アメリカ湾で
thanks
す。
to Starlink, we'll
時
be
代
going
はアメリ
live
カ
in
で
the
す。
Indian Ocean and chatting once
USA
again with
で
the
す。
ship recovery team stationed out there.
Yeah, I'm super excited about that. That's going to be totally awesome. But sit tight because first we're going to go to Dan for a quick status check.
Yep, hey everybody, good news, still looking good. Range is green currently. We're expecting another update on that in just about 4 minutes. It should be our final determination. Weather continues to look amazing. Vehicle and pad both looking healthy. We are a little over 80% on fuel, 95 on LOX in the ship. And then a little more than 2/3, it's looking like on booster. So we are on track today, looking good for a launch right now at 5:30 p.m. Central Time. All right, so we're going to do that right at the top of our window. Once again, though, we're going to be targeting to send Starship around the world for a splashdown in the Indian Ocean. We had a really quick check-in yesterday with the Starship recovery team out there on station. They're helping us to maintain the range and a whole lot more. So let's jump back out there once more today. We've got Suren Sinai joining us live from the boat deck out in the Indian Ocean, a couple hundred miles off the coast of Australia. Suren, how's it going, man? Welcome to the Flight 12 webcast. How's everybody looking out there in the landing zone?
アメリカ湾。Google は
Dan, it's a
メキシ
pleasure
コ
to
湾。
be here. I'm not going to lie to you, it's a little rougher than it was yesterday. Nighttime, it's hard to see the horizon, but we're looking at about 10-foot seas, and we're loving it, but it's rough.
All right, what's your guys' primary
さっ
job
きのお
out
じさ
there?
ん
I
は
mean,
寝
you're
てま
out
す。
kind of in
寝
the
て
middle
ない
of
のは
nowhere.
この
What are
人
you
で
guys
す、きっ
doing?
と。現場は寝てません。現場の
So,
人たち
like,
は
as you mentioned, like it's
一
usually
睡
a
はして
500
ま
to
せん。
600 nautical mile sail from shore.
ああ、
And our primary goal is a range clearing group. So like we come out here and make sure there's no one else in the area so the rocket can launch. But that kind of allows us to do our second goal, which is to conduct imagery of the rocket as it re-enters and as it splashes down. We get a lot of other data, but like the primary one is for sure imagery with an ensemble of maritime and aerial-based assets.
And talk to us a little bit because it's evolved over time. Kind of humble beginnings of getting those views to talk us through where we've gotten to now today.
インド洋のボートの様子だね。
Yeah, I think some people know, but like the
本当この
Orbital
ボートいいね。
are quite
このボー
identifiable.
ト欲
That's
し
the
い
buoys
ね。
that we use, and they were originally used as
スタ
sailboat
ーリンク、
racers.
スターリンクついてるから、
We
スター
kind
リ
of
ン
saw
ク。
it as a
Orange
Hail Mary attempt on Flight 5
こっ
to
ち
get
は寝てねえ
imagery
んだけど、
of
イン
the
タビューも
rocket
給
as
料
it
のう
came
ちは
down.
つれえところだぜ。
And we all thought it maybe would have worked, but we were super shocked and really pleased to see all of the buoys pointed right at the rocket as it came down, which was a testament to not only the scrappy engineering we were able to put together, but also
いくらで
the
も
rocket's
現場
ability
装
to
備っ
land
ぽ
right
く
on
ない。これ
target.
こいつ、
And then
撮
since
影
then,
なん
we
だよ。
kind of iterated more and more,
よく見たら
and these
撮影
buoys
の
have become
GoPro マウン
way
ト。
more robust
これ
and
も
have
多
now
分
a
ね、
lot more
カメラかなん
data
かのマウン
collection
トと
materials,
か
not
ね、
just visual imagery.
イヤホンつ
As
い
a
てるし。
result, they
あ、違
kind
う
of
の
are
な。
the
なん
most
か、
mature versions they've ever been.
こいつは違う
And
と思う。
it's
こい
really
つ
cool
ね、
because
よく見たら違
almost
う。
all the buoys that we're deploying,
なんか
even
現
now
場っ
for
ぽ
Flight
くな
12,
い。
we just got them off our back deck a few hours ago, are the exact same ones that were used for Flight 5.
And I saw a couple of user terminals. How Starlink kind of playing a role in this
現
entire
地特
operation?
派員って感じじゃない？
Dan, I'm not going
多
to
分
lie to you.
そう
If
思
we
う
didn't
わ。
have Starlink out
現
here,
地
we
特
would be
派員っ
screwed.
ていう
しわし
But
よく
just
派遣された
on
劇
like
団
a
員枠
usual
かな。
basis of
そ
like
うそう
working,
そうそうそう。
we're
そん
allowed
な
to
感
like
じ。
have calls with each other and like work on documents
現
with
地
each
で
other, send
撮影
things
す
to
る
each
の
other
は
in
もち
like
ろん
a
別
very
の人の。
timely manner because of the Starlink on the boat. But not only that, each one of these buoys
マ
is
スクし
equipped
たら
with a
ここで
standard
もらって
Starlink
働い
Mini,
て
the
ま
one
す
you。would just get from like ordering it commercially, and
ちなみにあ
that
と
allows us
10
to
分
not
で
only
す。
operate the buoy remotely, but also to get live stream data and telemetry, which is honestly
マスク
super
したらお小
useful,
遣い
and
も
I
らっ
don't
てみ
think
た
we
い
have another
な。
solution for without Starlink.
All right, before I let you go,
いいの
what's
先
it
生
like?
からお小
You're
遣い
out
もらい
there
たい
and then all of
な。
a sudden Starship appears out of the sky. What's that feel like, man?
Dan, I can't
Yep.
lie to you. It feels awesome. Just like being on the boat, not seeing any land for miles and miles, and then hearing the Starship crack down with its sonic booms and watching it breach through the sky. It is one of the most magical feelings on Earth, and
しわしよ
really
うかせ
excited
て
to feel
ホ
that
ールド
again
が2
today.
回かか
All
るに
right,
100ペリ
well,
カ。
thanks,
結局
Suren.
飛ぶに
Good
500
luck,
ペリ
man.
カだ。
Hopefully we're sending a rocket your way real soon. Thanks for joining us in, man. I'm going to send it now back down to Kate
わあ、
and
そう
Jake
だね。
for the latest progress
1
we're
ホール
making
ド。
at Cape Canaveral in Florida.
1ホー
Thanks,
ル
Dan.
ド。
Now, if we want to get to the moon and then Mars as fast as
1ホールド。
possible, there's really only one
Seven.
answer, and it's to launch a lot more
一
rockets.
発アウト。
Yeah, and to do that, we're going to need a few more
一
launch
発アウ
pads and
ト
support
にか
buildings,
けて、
which
そ
is
うしようかな。
exactly what we're working on
打ち上げ
over
は
in
ね、今日
Florida.
は
あっとか
So originally built for
9463
Apollo
の
and
部位が
then
落ちて
the
きた
space
スター
shuttle,
シップに
launch
当たら
complex
ないのだろうか。
39A has flown 126 Falcon missions since SpaceX reactivated the pad in 2017.
Yeah, I actually remember the day that we did that. I was able to host the live webcast for that first launch out of Pad 39A, and it was just so amazing to see that pad come back to life. And it's also exciting to see how today, almost 10 years later, the ongoing construction, as you see there on your screen, and the development that will bring a second launch tower to Launch Complex 39A. It's designed to expand our capabilities to support Starship launches in the future, while also continuing to support Falcon Heavy missions from the original Apollo Shuttle Falcon launch tower.
Yeah, and we're not done. We're also building a Starship launch pad at Flight 37. And to support the uptick in future launches, there's Giga Bay, a giant assembly and maintenance facility designed to prep Starships ahead of Florida launches. And when complete, this huge structure aims to hold 24 work cells in over 800,000 square feet of workspace. It's going to be a big building.
So much space.
So yeah, SpaceX's future in Florida is quickly taking shape with our very first launches on the horizon.
Exactly. A horizon that aims for regular trips to the moon. And speaking of moon, we've got another special guest for you today. And I think the last time you and I were on a webcast with this person was Polaris Dawn, as he was performing the very first commercial spacewalk.
That's right, Kate and Jared. I don't know if today will be quite as cool as doing a spacewalk, but we're going to try our best to make it as exciting. Like, thanks for joining us here today, man. You had a heck of an entrance on the way in.
It's great to be here. Yep, certainly great to do a little bit of a flyby. I think they should accompany all the great rocket launches, and we certainly got a great rocket out there on the pad. But wonderful to be back, and no surprise, it's always changing here. It looks amazing.
I was going to say, it's been a couple of years. What was your impression flying in? It just the lay of the land.
Well, I think it was actually maybe 10 months ago. I was here slinging pizzas. I got a new job now, but there's been so much that's changed even since then. The facilities look amazing. The technology that's coming in here, and of course, we had 2 orbital launch pads out there and a rocket that's just looking fantastic, especially from the aerospace.
Yeah, you said you got a new job. It's been a slow start to your first 6 months. I mean, you only sent humans around the moon for the first time. Bill and I kind of nerded out a little bit. Like, that was the last thing I worked on when I was at NASA, so seeing them go was just insane. Like, how's everybody feeling after the success of Artemis 2?
Well, I'd say I have the best job in the world, and I certainly work with an unbelievable team. I mean, as you know, that mission was a long time in the making, so I got to show up at the right time to see everybody put all that effort to put it in action. But what a great mission. Those 4 astronauts, you couldn't have had better ambassadors for humankind to the stars. I mean, they really brought us all along for 10 days. And we're getting ready for what comes next. We're going to start stacking Artemis 3. We got a lot of the hardware in the VAB already. And we're looking forward to seeing this thing fly. Hopefully at some point in the not too distant future, we're gonna join up in orbit.
Yeah, what's coming up next, and ultimately, like, based on the moon, that's the big focus. Like, what's kind of the why? Like, why are we doing this for everybody?
Well, I mean, and yes, we're certainly trying to get back to the moon, but what's coming up next? We're also building a moon base in parallel. And why are we doing that? Well, it's for a lot of the shirts I see around here, which is Occupy Mars. I mean, what a great opportunity. Go to the moon, return to the moon, build a moon base on the South Pole, interact with the water ice, right? Maybe work on some of those skills we're going to need when we're 4 days away from home for what we might need someday, more 9 months away from home. But other things come up too. You got Nancy Grace Roman. That telescope's going to launch later this summer. There's a lot of great, exciting things going on.
SpaceX, we're custom built to try and make like multiplanetary. Really excited to see Starship, send people to the moon, all of the different pieces working together. It's going to be a really exciting future.
Oh, absolutely. Well, thanks for having us. Great to see everybody. Again, I know a lot of hard work goes into a moment like this, so we're all rooting for you, and we're looking forward to meeting up next year in Earth orbit.
All right, man. Well, I'll let you jump back in there. We've got about 4 minutes to go. Toss it back down to Kate and Jake.
I think it's safe to say we could listen to you guys yap about the moon pretty much all day. It's so inspiring to hear about the future of exploration on the moon. And if you caught the show yesterday, you also heard some more future space exploration news.
Yeah, that's right. From to Mission Commander Chun Wang will be one of the first humans to become an interplanetary traveler. Don't think I've ever said that word before. While also joining Starship's first mission to fly past the moon.
Yeah, amazing. In fact, that Dragon capsule that you saw there was Dragon Resilience. That is the same Dragon spacecraft that Administrator Isaac Ben flew in both Operation 4 and Polaris Dawn. So it's a good one. Again, we're now coming back into a terminal count again. Anticipation is definitely growing as we proceed towards our second attempt.
師走を中国系の顔をしているけど、だからどうしたってことではないけれども。
Starship version 3, massive upgrades across the vehicle that you see at the pad there, as well as the pad itself.
The good news is we've had a pretty quiet countdown today. We are looking at a green range still. We're not tracking any issues with our weather, with the vehicle, or with the pad. We are now getting into the phase where we're closing out prop load on the ship. And the booster is going to close out in about 15 seconds or so. With this, you're looking at 11.5 million plus pounds of propellant on board Starship and Super Heavy. We're going to get the pad itself ready, push back all of the propellant that's in those lines running from the farm to the launch mount. Just kind of harden the area to get it ready for launch. We're going to peek inside, hopefully see the engines do a little wiggle as we do our final steering check. That'll happen at T-minus 100 seconds, and then after we get to T-minus 40. If you tuned in yesterday, you're very familiar. If we need to hold, we can go into what's called rapid recycle, essentially, where we can hang out at T-minus 40 seconds. It's built in. Only going to hold if there's an issue. We're currently tracking one. But right now we're looking good.
And then once we do pass T-minus 40 seconds, a number of events will occur in quick succession. That is when the QD vent gate will clear the gas commodity lines that connect the pad to the vehicles. Both the ship and the booster will configure their comm systems for flight and will rapidly run leak checks on gas and fluid tanks. And the booster goes to internal power, and its engines will get their final priming for launch, while the ship's engines begin their assembly profile and arms the automatic flight safety system.
Yeah, and once we pass T-minus 40 seconds, we still have the ability to rapidly reset under certain conditions back to T-minus 40 seconds.
Getting some engine wiggles here. These allow us to check out the thrust vector control actuators on the. It's important to make sure that they can steer.
Yeah, that's definitely right. And flame diverter on pad 2 activates at around T-minus 17 seconds. And what is essentially the point of no return at T-minus 10 seconds. If we have a hold close to T-minus 17 seconds, there's a chance we could recycle, but the closer we get to T-minus 10, the lower that chance becomes. T-minus 1 minute.
Yes, at this point in time, we're going to stop talking. We're going to let the rocket take over and listen to some amazing pad sounds of the first flight of Starship version 3.
あっと師走8回1分切った。
40秒。ホールド。ストップ。
All right, we are holding. We're just waiting for the fuel pushbacks to complete into the prop farm. We did hear that did just complete, so expecting them to reset that hold shortly.
まあ焦らず行きましょう。焦らず行きましょう。焦らない。
あっと師走8回相変わらず何も分かってないと思われる監視。
カウンタウン。
あっとダブルでケーズ再開。
カウント。あ。来たよ。
あっと師走8回スタート。
20秒前。15。
匿名 21H さんだって離陸はできてるし大丈夫。
信じて。
8 7 6 5 4 3 ignition.
あっと師走8回ミッション。あっとダブルでケーズイグニッション。あっと師走4回。あっと HNN CBEPX CNCTPM CCCT NM CO グループブスク。
Booster Raptor, chamber pressure nominal.
おー、いいぞいいぞ。
あっとしわしおが綺麗な炎だ。
All right, we are T+30 seconds into flight, seeing 33 out of 33 Raptor 3 engines on booster V3. Ascending over the Gulf now, coming up on maximum aerodynamic pressure.
すべて作動中です。
Booster and ship, avionics power, telemetry
燃料
nominal.
もね、3分の1使用。
Systems looking good. We're just passing through the period of maximum dynamic pressure.
かっこいいね、やっぱり。独特だよね。
あっとしわし
A
お
little
か
over a
断熱
minute
材の剥離
into
も認め
flight
ず。
now.
そう。
Vibrations chilling out here
あと、
at Star
表面の
Factory
後
as we
半の
continue
測
to
りもな
watch
い。
Starship Flight12 arc out over the Gulf. The next major thing
今だ
coming
か
up
つな
is
く
going to be
安心
hot
感のある打ち上
staging.
げ。
Booster prop systems nominal.
Reminder, we do what's our version of MECO. Most engines cut off, so we're going to shut down all but 5
もう間もな
of
く
the Raptor engines on the
第
booster.
1弾をステージセパレーションしま
And
す。
then after that
あっと
happens,
しわ
we're
しお
going
かエ
to
ンジンは
ignite
前期問題
the
なしと
6
認める。
engines
2
on
分
ship
24秒
while
ま
they're
で
still attached.
この調子です。
We have clamps that
今
hold
回
the two
その
together.
分離がな
Those
か
are
った
going
ダ
to
ブルで
retract
すね。
inside of that
すでに
hot
マックス
stage
9も超え
ring,
ました。
kind of protect
あ、
them.
エンジン1個止まった。
We
エンジン1
had
個止まっ
one
た
of the
ね。
engines go out, still flying on 32 of the Raptor engines. But again,
私の
once
と
we
こ
get the
私が
hot
考えたけど
staging,
1個エンジン
those
止まってます。
6 engines on the ship are going to ignite.
エンジンって1個停
We're going
止。
to do it in a little bit different of
この1個エンジン停止は何を意味するかわかんないけど。
sequence on version 3. Essentially, those
エンジ
3
ンは1個
RVAC
止まって
engines
る。
will ignite first. Almost immediately after, just one of those central engines is going to
打ち上
ignite.
げより
And
2分
that's going to
22
give the
秒で
booster a bit of a
セパレー
kick,
ションです。
sending it in a
では
no direction,
見て
followed
くださ
shortly
い。
あっとしわ
after
しお過去
by
コラ
the
テラ
other
ル
two.
ダメージだから平気平気。
よしよし、
あっと
大丈夫だよ。
ダブルでケーズなんか画面に生え飛んでませんか？
We're through
エンジン
MECO.
ね、
Each separation.
今回ブースターのエンちょっと変わってるよ。おー。やばいね。
There you go, successful hot staging separation.
映像かっこい
We're
い。
not seeing as many booster engines ignite as we expected for boost back,
あっとダブ
but
ル
we
で
are
ケー
seeing
ズを。
6 good engines lit on ship.
なんでか、
It looks like we just had an early boost back shutdown. Again, a reminder, the booster was planned to essentially head into the Gulf for a splashdown, but it has shut its engines down early on into boost back.
映像は、
あっとしわしおかじゃ
待って待って待って
We
待って
just
ちょっと待って
see one of the RVAC, so we're now running on 5 engines
外側
on
のね、
ship.
エンジン、外側のエンジンのうちの1個が停止してます。
We do have engine out capability, so it's going to continue
下
into
側のエン
its
ジンが
ascent.
停止してるもんで、どう
We
なっ
got
てんだ
booster
ろう
on
こ
the
れ。
left there, ship on the right.
エンジン1個止まってるけ
Jet
ど、
avionics power
Again,
and
we are
telemetry
not
nominal.
planning
double
on
the
bringing
case, oh,
the booster back for this
あっと
flight,
しわ
as
しお
this
かじ
was the
ゃ
very
冗長
first
性があ
time.
るから駅兵器。
まあ、こういうこともあるから、こういうテストも兼ねてやってるかもしれないし、
All right, so we're about 3 minutes, 50 seconds into today's flight. Just a
とりあえ
reminder
ず
that
視
the
線の
ship
乱
planned to
がないか
burn
ら、
its engines
大丈夫だと思う
for
よ。
about 8 minutes and change.
うん。
About 8 minutes and 11 seconds was our planned timeline for today. That could shift slightly as
エ
we
ンジ
do
ンが
have
1個
one
止まっ
engine
て、
out
新
running on
しい
one
ラプタ
fewer
ー3だからって
RVACs.
のもあるかもしれないけど、ラプター3の関係で、途中でエンジン止まったり、
Again,
ここはス
continuing
ター
to
シッ
watch,
プ
the
のエンジン
booster
が
did not
必
complete
要
its
だっ
boost
たり
back
する
burn.
の
We
か
did
な。
not see all of the engines ignite that we expected. Are
Well,
continuing to
well,
get some views
well,
from
they're
it
gonna,
though.
yeah.
That's going to make a splashdown somewhere in the Gulf.
で、この上
Reminder: we
は、
clear air,
ブ
sea
ース
space,
ター側
everything.
の映像
for
で、
these
向こうは
launches.
スターシップ側の映像でいいのかな。でもね、これブースターの本体の横ぐらいについた映像だよね、きっと。
All right, so we are coming up
エンジン
on
が
T
外側の、
plus
外側のエンジンが見えて
5
るから、
minutes.
外側についてるんだよね、カメラが。
Ship continuing to fire 5 of
ちょ
the
っと、
6.
今までにないね、カメラ配置ちょっとね、困惑しつつ、引き続きスターシップ
Standing
側の
by
エ
for
ンジンが
callouts,
ね、
making sure ship's on its planned
なんか外
trajectory.
側
Again,
の
we are
時は
planning
2
a
しか動いてないか
suborbital
ら、ちょっと
trajectory
気に
for
な
the
る
ship
ぐらいか
today.
な。なんか意味あるんでしょ
booster giving us some views as it continues to make its way back down towards the water. All right, so a little over 5.5 minutes of flight. Kate, Jake, you guys with me? It looks like booster's starting to come in hot.
Yeah, we had the opportunity to stand outside to watch launch, and wow, that was incredible.
Yeah, that was really loud, really shaky, and I was actually surprised how fast the booster got off the pad during the stack. That was quite incredible.
Absolutely. So we have views here from the booster coming back down, making its way into the pretty cool to see. Great news there.
外れそうっていうか、すごいガタついてるね。お、来る。
Once again, we were not going to bring the super heavy booster back to the tower. We were planning on having it land in the Gulf.
And it looks like the booster ended its mission there in the Gulf, but we've got a ship still flying. Great to see that. Still have 5 out of 6 engines there on S39.
Yes, we also heard good chamber pressures as well on those engines that are lit. We do have engine out capability. We do see that we have one of the RVAC, one of the Raptor vacuum engines that is currently out, but that's okay. Ship is continuing on. Amazing views of planet Earth there in the background.
Yeah, I love the S39 decal there. That just gives the ship a little bit of character. And again, all these great views brought to you by Starlink, of course.
あっとしますよか観客。なんかよくわからんが、とにかく拍手しとくか。
それでいい。
Obligatory shout out to the entire Starship
camera
electronics team. Did a whole lot of work to get these upgraded cameras. A look inside of the ship's skirt, you can see those 3 center engines ignited. The RVAC continuing to fire as well. We did see at least a couple engines fire up on booster for that landing burn before we lost contact with it. We should have just a little over 20 seconds to go. We'll see if the burn extends a little bit. For the engine out, essentially you can run your engines a little bit longer or throttle up a little bit more to account for the one engine not being lit. So right now we are standing by for SECO.
あっとしますよか。名前を言ってはいけないあの方。さっさと配信を閉じたもよ。
は？なんで？なんで？
Continuing to go a little bit longer.
飛んでるよ。まだ飛行中ですよ。飛行中。ただいま飛行中。
あっとダブルでケイズ X でなんか忙しいって言ってましたね。
5 engines still burning on ship.
まあ仕方ないね。ギリギリまでやってたんだろうね。で。スターシップの方は現状は、まあ、通信状況は見ての通り安定してて。
あっとしますよかなんか旅行に行くとかなんとか。
いいなぁ。
Coming up on T plus 9 minutes.
ただ本当に今回気がかりがね、3機中、でも、やっぱ、飛んでるからいいのか。燃料も残ってるし、いいのかな。
And starting to see shutdown.
ああ、止めたね。周りの3機のエンジン、
shut down. Sea levels are shut down.
うん。エンジンは止めて、ちょっとね、あれかな。スピードが足りてないかなぐらいで。うん、燃料もね、スプラッシュダウンの時に使う燃料が残ってるぐらいかな。
On the ship orbit insertion. But we have shut down again. We did run longer as we were engine out. We were flying with 5 of those 6 Raptors pretty much the whole time.
ああ、いいね、いいですね。最高ですね。
Ship FTS is saved.
あ、そうね、書いてあるね。ブースター19はランディングに失敗って書いてあるね。で、こっから。
Alright, well, we definitely got a ship in space right now.
7分ほどは飛んでるかな。
あっとダブルでケイズなんで推進方向にスラスター吹かしてるんですかね。
それはなんでしょうね。向きを変えてるんじゃないんですか。 なんででしょうね。なんででしょう。
As you can see, the teams are incredibly excited to see Starship there in space. We are awaiting the call out of nominal insertion, so we're going to stand by for that. We can see the flaps moving here, actuating. But wow, the cheers here in the lobby are certainly almost as loud as liftoff was.
Yeah. Man, a lot of action going on. And, you know, we said at the top of the show, excitement guaranteed. And we're only 11 minutes in. We still have a lot more to go here on the mission today. So all objectives are done on the booster. So now all eyes are on the ship as we get ready for our in-space objectives.
Exactly. So like I said, we're still standing by to hear the call out for nominal insertion, but we've got a few minutes before the next milestone. So we're going to continue. We've got some amazing views here of the ship. Wow, it's just that this is our planet. This is our home.
どんな感じなんだろう。打ち上げて。
アットか9463知られざる世界を思い出す映像。
As a reminder, the
アット
objectives
しわ
for
しよ回論。
ship
そ
today
ろそろ出てきてもいいか
not
な。
only
ア
included
ッ
the
ト W で
separation that we
今回は
saw,
円のようの
but
結構
we're also
東側
planning
なの
to
で長い距
deploy
離飛びます
20
ね。
Starlink simulator satellites as well as
でもいつも
2 Dodger Dog satellites. That's what our internal teams refer to as our newer satellites.
割と東寄り。
We saw a preview of those earlier. We should see those deployments here in a little bit. We're also hoping to perform a relight of a Raptor engine as well.
Yep, that's exactly right. And the relight will look a little bit different this time. We're hoping to get a little bit of a longer duration. Of course, we got to see once we get there. And that relight won't actually be changing our orbit necessarily, but we're doing it more so as a technology demonstration.
火星フライバイを決める人物ではないかと言われているお人です。チュンさんです、チュンさん。ちょっと、チュンさんだけじゃわかんないから。
For those of you that maybe just recently tuned in, you missed a pretty exciting almost 13 minutes. We had a liftoff pretty much on time, almost right exactly at 5:30 p.m. We did have a brief hold at the T-minus 40-second period, but we were able to proceed through that, and we saw a gorgeous liftoff. Jake and I were able to stand outside and witness that with all of our colleagues, and what a moment. I'll tell you what, it is a heck of a lot louder out here than it was at Ad Astra.
Absolutely. And a couple things I noticed on the way uphill today on the ship. So obviously it looks like we lost one of the RVACs on the way, but that is a good way to demonstrate our potential engine out capability there. So
exactly.
I think we actually saw the 3 gimbaling engines kind of gimbal over a little bit to compensate for that offset and thrust. So that was really cool. That's something I know the team's been, we've analyzed that since Flight 1 all the way back. So it's something that we've thought about quite a bit, and it was kind of cool to see it in action in real life today.
Yeah, absolutely. If you couldn't tell, Jake is on the Raptor team.
Yeah. But one non-Raptor thing I noticed also back on the when we had the shot of the aft flaps. It's a little weird. We have tiles on the leeward side, so not on the side where we're going to see heating. And you might be asking, why are we putting tiles there? I had the same question actually. So I talked to some of our heat shield engineers the other day, and we're actually running. Yeah, here's the shot right here. Great. So the fact that we're seeing all these tiles still on the flap right now is really good, because that actually was one of our experiments where we wanted to test different connection methods on the way uphill on ship. So actually Ascent. So it looks like most, if not all, the tiles are still hanging on there. So that's actually a really good data point.
Looks pretty good to me. Now, once again, this view is from the side of Starship, which is basically the second stage of the Starship vehicle as a whole. This is one of the flaps on the vehicle that helps to control its position and attitude as it is orbiting, and also helps to control during re-entry as well. That's a critical phase. I mentioned earlier that we're hoping to deploy those Starlink satellite simulators as well as perform in space relay rocket engine. If all of that goes well, we will be targeting a soft splashdown in the Indian Ocean. We heard from Suren on the recovery team a little bit earlier. They are standing by waiting to receive the ship that we see here.
All right, let's send it upstairs. Dan, how's it looking?
Hey guys, we are looking good. It does look like we are within bounds of what we analyzed if we were down one of our RVAC engines, so I wouldn't call it nominal orbital insertion, but we're in on a trajectory that we'd analyzed and it's within bounds. So team's continuing to work through it with that engine out. They're working through some steps on the engines. We probably will end up skipping the Raptor relight for today, but it sounds like we should still be on for payload deploy, at least at this time. So very dynamic moments right here with the ship, but we do have it in space. It is on a trajectory now, headed towards the other side of the planet, and then a splashdown in the Indian Ocean. It's going to start to get darker. We're heading into an orbital sunset, so we're gonna have darkness for a little bit, and then it'll brighten up once we're on the other side of the planet, and hopefully looking at some good daylight when we re-enter into the Indian Ocean.
F2 プールは世界最大のビットコインマイニング事業者でした。はい、イベント中らしいですね。燃料吹いてますね。ってことはスプラッシュダウンできないんじゃない？海にドボンができない。ドボンできない？ドボンする？まあ、なんとなくお察しですけど。
All right, so we're a little over 17 minutes into flight. If you're just now catching up with us, we did see a liftoff right at the top of our window. Super Heavy getting off the pad, initially lighting all 33 of those Raptor engines, got through a successful hot staging. Initially lit 6 engines on ship, had one RVAC go out on the way uphill, but still able to make it into space. And right now we're trying to see if we are going to get into payload deploy still. Coming up right on the part of the timeline when we were expecting it. Look inside a Starship there. Oh, I see a door opening. Looks like Hal didn't wait. Pez door is open. Just a reminder, we've got 22 deployables in the payload bay today. 20 of those Starlink mass simulators, and then 2 are Dodger dogs, as we like to call them internally, sitting up their modified V2 Starlink satellites. Those are going to be testing a bunch of components that we're planning to fly on Starlink V3, and we've also got them outfitted with a number of cameras for another tech demo that we're trying out on this flight. We definitely are looking for a way that we can look at Starship's heat shield while it's still in space. You can kind of only see so much from the cameras and the flaps. You can't see everything kind of on the underbelly, and one of the only ways you can do that is if you got something else flying near it. So we're going to attempt to, our final 2 satellites going out the door have a suite of cameras on them that are going to be looking back at the ship. We're going to be in nighttime, and so we've got, sounds like we're getting into payload deploy. We'll be in nighttime. They've got some powerful flashlights on them to try and illuminate the ship's heat shield while we fly away from it. So we see some Pez motion. Two down, 20 to go.
ここにはね、雪ですね、多分。
As a reminder, that's one of the things that we upgraded in
結構した雪みたいな
version
のも
3.
飛んでるん
Kind
じゃ
of
ない
gave
かな。
a little soup up to the PEZ dispensers, so those satellites going to move out a little bit quicker than they did on previous Starship flight tests. So first 2 out the door, 2 more on their way out.
確かにそれならば天が行きますね。
嘘でしょ？燃料の上にあるからね。タックの上も冷たいだろうから、結露するね、きっと。イェーイ！綺麗に飛んでった。いってらっしゃい。どっかでも見つけるけどいってらっしゃい。1枚ずっとあるんだよ。あれ？
4 down, 18 to go.
多分取ったんだと思うんだよね。
しわしようか観客。とにかく完成上げとけ。ダブルでケージ100式が出ました。
Flexing my basic math skills here today.
今はね、
Again,
もうね、
the
あってるの
majority
は
of this
諦める
stack,
として
20 of
も、
these 22 satellites,
まあやれることをやる
essentially
ね。
just
ね。
mass
せっ
simulators,
かく打ち上
so
げた
they're
し。
roughly the same size as those Starlink V3 sats
飛
that
行も
we're
一応続
hoping
いて
to
るし、
fly later
イン
this
ダー
year.
までは届くだろう。うん。できればここにね、外ライトつけてほしいね。
Oh, and from this top-down view, so you're looking down at the stack, those 2 satellites you see on the very top, that they'll look very different. They've got solar arrays, they've got a bunch of other deployables on them that we're going to be testing out that are going to be V3 tech, and they've got 3 engineering cameras and then 1 other camera that's hopefully going to be giving us some views of Starship in space. But we will see how that works. Again, this very much a tech demo. We're going to deploy those. The satellite's going to kind of try and turn everything on, look back at Starship. And the primary reason we're trying to do this is to get some views of the heat shield.
まだやらないかな。
プオレルブルーおはようございます。
おはようござい
2 more
ま
out
す。
the door.
そしていらっしゃいませ。
2 more out the door, and I think that counts, or that comes up to 8 total.
だって USA!
As you can tell, the teams are stoked to see this demonstration happening. It's pretty incredible to see this happening live from space. Now, as we noted earlier in the show, but worth repeating, this Starship, version 3, is built to deploy up to 60 of Starlink's more advanced V3 satellites. Everything's V3. Designed to offer 60 terabits per second of downlink capacity per satellite. Now, that is 20 times more than each Falcon 9 does today. Incredible.
All right, I think that's number 10 going out the door.
だね。さっきの突然の USA は。
Yeah, there it goes.
意味わかんない。急に会場
So
が
yeah,
盛
the
り上が
camera
る。
view you have on your left screen there is basically right at the
でもそれはま
bottom
たね、楽
of
しい。
the payload volume. So the
外の映像
kind
は
of
バンド映像
dome
だけど。
shaped structure you see there is that's actually the top of the fuel tank.
途中の何枚かは出さない方がいい状態だったとしても順番に全部出した途中ダブルでケージスターシップは大分県佐市が飛ばしています
the light through the open PEZ dispenser door that you see. That's that sliver of light. We can see the Starlinks here deploying as each one comes through.
また飛び出たぞ。あと何枚だ？私すごい気になるの。このダミーでは、
As we mentioned, we have 20 of these Starlink simulator satellites, and then we have 2 of these specially modified, as we call them, Dodger dogs here around here. Those, as Dan mentioned earlier, they have some V3 tech on them, some solar arrays, and those will be the last 2 that will be deployed today.
Yeah, that's right. And seeing this, as I think Dan called them turbocharged or supercharged PEZ dispenser, it's definitely coming out much faster than our previous flights, so that is really good to see. Yeah, look at that. And especially once we, fill Starship up all the way with around 60 or so of these Starlinks, being able to deploy them fairly expediently, is going to be important for designing the overall mission profile.
Yeah. Now, fans of Starship may know that Starlink enables lots of unprecedented views, both from space as we see here and on Earth. In addition to the dozens of cameras on Starship itself, we also have mobile Starlink camera kits deployed in the Indian Ocean.
Yeah, Starlink also connects our aerial cinematography units on the ground at Starbase and at other strategic camera spots around Texas.
It's all part of how it all comes together to tell the incredible story of Starship both on and off planet.
Yep.
3枚というか3枚と6枚かな。
We're getting low on the stack. Looks like we got 2 more of those simulators to go out.
多分ね、残り6枚だと思う。
for our Dodge Dogs as modified Starlink satellites.
2枚ついてる。
Just a couple of updates while we continue to watch Payload deploy. Did get confirmation we're going to be skipping that relight of the Raptor engine, just due to everything that we saw on the way uphill. Those sea-level engines, we're going to use them for a landing burn, though. They are still capable to be used for that, so we'll still look to do a controlled landing in the Gulf. But no in-space relay.
残り多分4枚。2枚じゃなくて4枚だと思う。
All right, I think that's 19 and 20 headed out the door. And coming up our Dodger Dogs. So these are modified V2 Starlink satellites. We do have a number of cameras on these that are going to attempt to look back at Starship. We're not going to get this video in real time. We're going to try and turn it around if we do get some video down. So don't worry, if we get views of Starship from these satellites, we will be sharing. These will be exciting because again, they're really a tech demo, getting our chance to test out some of the technologies for version 3. All right, I think that's 18 and 20. My basic math skills are failing. All right, here we go.
金は確かに金はないと思う。来るぞ来るぞ。何やってくれるんだ。さあ、ダミー衛星とは違う。目的を持った衛星。
We're standing by for Starship, basically to serve the first Dodger Dogs to low Earth orbit.
いってらっしゃい。どう？まず1枚。
One out the door.
1枚いったよ。
In this view, you can kind of see on the right side of the satellite, you see some bright white spots on the flashlights beneath them. The camera is going to attempt to look back and image Starship's heat shield as it flies slowly away from the vehicle.
あ、出した。全部出した。はい、これで全部展開を光って素晴らしい。目的映像の映像完璧。すごい。
It almost looks like the light is shining right at us.
これすごいぞ。1台につき2枚です。
Yeah.
It is always sunny in space.
1台につき2枚
Always
です。
sunny in space, and that looks like an empty payload bay. So that's exactly what you want to see there. That's
今の
great.
映像すごいよね。
So yeah, with payload deploy complete. Oh, you can see the door closing there. All right.
でも今の完璧だと
So yeah,
思う。
with payload deploy complete, Starship will
今
now
の入り方
close.
完璧だと思ったけど。全部コンプリートしたと同時にしっかり光らせてくれて。
Yeah, Starship, we closed the payload door, and we're going to continue to coast around Earth all the way to the Indian Ocean. So still a lot of major events to come today. Sounds like we're not going to hit that Raptor relight, based on what Dan was saying, but after that, of course, we'll have the atmospheric reentry and splashdown. And with that, we're going to go on another quick coast.
So sit tight, enjoy some amazing space views and the space jams, of course. And we'll be back in a few minutes for Raptor relight, or excuse me, not for the relight, but we'll be standing by for atmospheric reentry.
そのすぐ出しちゃってもさ、映像楽しくないから。 さあ、こっからはね、しばらく弾道飛行が続くんで、しばらくだね。リエントリーは17分後です。なんで、こっから17分間は、まあ、ちょっとね、予定が変わってるから、10分ちょっとぐらいが10数分かな。こんなもんで多分、帰ってくるんじゃないかな、早めにちょっと。まあ、エンジンの再点火はできなくても、それでも、大気圏突入するときの、ね、いろいろ、機体制御とかいろいろできるから、ね。
H-897G タンク損傷してると思うのでスキップじゃないかな。
だからスプラッシュダウンはできないと思うけど、まあ、再着火と、着陸に向けた燃焼はできないだろうけど、空力制御の関係は一通りやると思うな。だってそうしたらもったいないもんね。せっかくこんな巨大なロケット打ち上げたんだから。これはフラップの先っぽにくっついてる。フラップパタパタ動かしてる。なんだろう、次回どっち行くんだろう。今回エンジン周りでいまいちな結果が出たけど、予定ではね、フライト13からはね、地球周回軌道に乗せてく予定なんだよね。
海にドボンさせるならエンジン点火して細切れにしても、いや、
なんでもないです。多分燃料が抜けちゃうんじゃないかな、先に。もし、
そうすると H-897G スプラッシュダウンはできると思います。着陸用の燃料は別タンクにあるので、コーヘルブルー今回のジャーバージョンアップ入ってあちこちテストし直し状態なんでしたっけ？
そうか、予備の燃料、着陸の燃料、エンジンつくのかな？外側3機使わないから、外側3機いらないから、やるのかな？まあ、お楽しみに。で、今回の機体はバー3です。バージョン3。これまでのスターシップと違うバージョン3です。で、ブースターもね、同様にバージョン3で、打ち上げの車上もパート2のね、最新モデルで、打ち上げの車上から今回は全部がね、新規。ほぼほぼ新規で作られていて、発射場もね、これまでのこうなんだろう、なんていうかね、五徳の上に乗ってるというか、コンロの五徳の上に乗ったようなやつから、なんかこう左右に吹き出すタイプにね、新しくしたっていう経緯もあったり、タワーも新しくしたり、ブーターもエンジンね、ラプター3使用してみたり、エンジンもね、新しいエンジン使ってる。で、ブーターの先端部分も、見た目の特徴だけや、先端部分の耐熱、なんだっけ、分離するときにこう、耐熱皿がついて、耐熱のお皿がついてるんだよね、前のやつは。お皿もなくなったしね、重たいウェイトが。で、スターシップ本体については、大きさが確か伸びたんだっけな。一応、低軌道に100トンまで打ち上げられる能力があるんではないかなみたいな感じで作ったと思うよ。何が変わったか？何が変わったんだろう。何が変わったの？見れるところで何が変わったんだろう。ブッダは結構、ブッダはね、いろいろ変わったには変わったけど、グリッドフィンが、これまで4枚使ってたものが3枚になったっていうのがあったり、着陸ピンっていうか回収ピンっていうか、ピンがね、これまではタワーにピンを引っ掛けてたんだけど、ピンをやめてグリッドフィンでダイレクトにドボっていくスタイルにしたり、いろいろ改良ある。スターシップ自体はいろいろ改良あるけど、なんだろうね。ドッキングポートについた。そう、ここに、この謎の突起物、エターの世代の突起物がついたぐらい。 見える、ぱっと見一瞬でわかるポイント。突起物が4つついてる。乗り換えじゃないかな。どうすんのね、次回。
あっとしわしようかこれドッキングポートだったんだ。
そうです、そうです。ドッキングポートなんです、これ。
あっとか 9463V3 もまだまだ課題山積だね。
そうです、だってね、まだまだね、こっちもんなんで。こっちものは大
あっと
体、
ユーザークブ 5H オブ8クズなのじっちゃんと正常な姿勢で大気圏突入できるだろうか。姿勢制御の動力源はタンクなやつだったはずだが。
入ってんじゃないだろう。大丈夫ですよ。信じてやってください。信じて。もう。SpaceX の実力を見せてみますよ。大丈夫だと思う。一応その、ピンについてはこういう予定。こういうことができるよっていうスタイル。そのピンとピンを接続して、こういう風な接続になるよーみたいな。そのドッキングのためのパーツがここです。できるのかな？できるのかな？
あっと少子用回論。君たち花火は好きだよね。
はい。
か
花火は好きです。私も花火は割と好きです。まあ、できれば帰ってきてほしいけどね。スピードは上昇している。機体の高度は下がっている。機体の高度は下がっている。これはアフリカ大陸を抜けた先あたりで落下してくるんじゃない？希望岬で落とすんじゃない？この人たち。また怒られるの？
あっとダブルでケースここからがマグマなんです。
ねえねえ。これ来たぞ。スターリング衛星を持ってきたね。すごい。いますね。さに3程度。宇宙で見たスターシップ。これが見たかった姿なんですよ。
あっとしわしようかこれだよ。これあっと
すごい
ダブルでケースを。
宇宙から見た。ドア閉まってく。でかいイカちゃんが映ってる。でかいな。
All right, so
いや
surprise. Looks like our cameras did work. We've made contact with both of those satellites.
すごい
We're
結
going
構
to
やられ
roll
まし
that
たね、今の
back
は。
again.
あっとしわしようかやるじゃん。
Again, this
わかってる
is
の
a
ね。
view
笑い。
from
あっとクオレルブルーカメラ衛
from
星
one
を
of
同
those
行させ
satellites
てる。
as we
そう
deploy.
で
It looks
す。
like
今
this
回
was from
ね
the last one
最後の
out.
2機はね、
Flashlight turned
リ
it
アク
on,
ションコイ
taking
ル
a
と
look at
ね、
Starship
カメラが
in
ついてるんで
space.
ね、撮影ができます。
The way this system
なんで、
is
撮
set
影
up
がで
is
きるよう
the
に、
satellites are
そ
essentially
の中
recording
の
it,
ね、
then making
スターシップの
contact with
耐
our
熱
Starlink
タイルのチェ
constellation
ッ
and
クをす
then
るために
transferring that video back
積ん
down
でき
to
た。
us on the ground.
積んできた。ただ、タイルのチェックはね、
That's a
できな
Starship
か
in
ったんじゃ
space.
ないかな。でもね、なかなか
Aside
こ
from just being really cool, this was our
う、
test
この
to
感
try
じ。
and develop a free flyer that we could fire outside of
本当にすごい
Starship's
ですね。
payload bay, look back at it, and then do
なん
essentially
か
a
未来を
pirouette
感じます
with
ね。
Starship to get a look
ち
at
な
the
みに
heat
今、
shield. Where
現
it's going to be
在
really
の地点
important
は、
when we start bringing these things
この
back
辺
for
にい
a
ます。
catch,
違う違う違
which
う。
we are hopefully doing
現在
in the
この
not
辺にい
too
ます。
distant future, as they are intended to
こ
be
こを今飛行して
fully
るんですけど、
reusable. But this will give us an
速
opportunity
度
to
は
look
ね、
at the heat shield
速度は
while
加速して
Starship
る。
is still in space.
あ
So
っとしわしようか
there's a
12ミ
glimpse.
リぐ
We'll
らいの
see
広角
if
レン
we
ズか
get any more video down from
どう
those
どう
satellites.
も
But
つくかもしんない。
I mean, that's one we've been
で、
chasing
今、
for a
だ
while.
ん
So
だんね、
really
この
cool to
辺
see
も
it
高度
come
が
to
ね、
fruition here on Flight 12.
多分この辺で100
All right,
切っちゃうんじゃないかな
on
と思うんだよね。
40 minutes into the flight. and we should start hitting
だいぶ当
the
初の予
reentry
定よりは早
period
く
in the
大
next
気圏に突入すると思う。
7 minutes or so. You'll start to see a light show building up. As we had talked about, we did skip that on-orbit relay of the Raptor engine.
皆
It's
さんが
not
求めてた映
needed
像が
for our
ついに届けられました。
trajectory or anything. We are on the suborbital trajectory to splash down in the Indian Ocean.
そうだね。
We
ア
are
フリカでは
going
ね、
to
接種
attempt
が
a landing burn. We'll see how they perform when we get
さあ、
there.
どうす
And
る？
just a reminder, we are going to be stressing the ship on the way in. We're going to intentionally do a maneuver where we're going to kind of pitch the nose up and deploy those aft, those bottom flaps to really put a lot of pressure on them. So we'll see how it does through that maneuver, and then we'll be doing kind of a final banking turn before we get to a landing burn. So all that coming up in a few minutes. The light show should start beginning real soon.
多分ね、現地でね、現地のスタッフがっかりじゃない？現地スタッフがっかりしてるんじゃないかな。あとは飛行機近くまで行くのかな。ちなみにいいね、大丈夫、全然問題なし。現在のアフリカ南側の航空機の状況、クリアですね。大変クリアですね、この辺。で、最寄りにいる飛行機は、SpaceX に関係してそうな飛行機はいないのかな。撮影に向かったと思われる飛行機はいないね。
あとはいいぞ。B さん T ヒーローが出てくるときにキャスターの後ろから驚かすように出てきて草だったことあるよね。
ある。なんだこいつはってぐらい思ったもん。なんだこいつはだもん、本当に。なかなか面白い演出でしたね。ヒーロー先生またやんないかな。なんだこれ、その周辺飛ぶ飛行機いないな。115キロ。115キロ。
あっとしますよかキャスター。あ、乱入者って親分はあでしたね。笑
いいよ。ああいう自由なね、会社はいいんですよ。ああいう親分いいじゃないですか。私だったら面白いなと思うよ、ああいう親分も。あ、映像が光り輝いてきましたね。とりあえず大気圏突入する姿勢にはなってるみたいです。あ、でも意外と落下しないね。意外と落下しない。もっと早くズボっていくかと思ったら、あ、でも早いと落下しないか。姿勢が少し変わったぞ。じゃあ姿勢、フラップを動かしたのかな。前ひれの方を動かしたのかな、少し。綺麗ですね。綺麗ですね。一応予定
あっとしますよかこの色。何の色だろう。
なんでしょうね。私、色の識別苦手なんで、色の識別が。普通、リエントリーは、だいぶ早いね。3分ぐらい。当初の予定より3分ぐらい早くリエントリーに入ってる。まあ仕方ないね。仕方ない。
あっとダブルでケイズドアの炎色反応でしょうか。 あと HNN、CBEPX、CNCTEM、CCCT、NM、CO ブルプラズマが綺麗ですね。あとクオレルブルー大気圏突入時には断熱圧縮で周囲の空気がプラズマ化するんでしたっけ？
うん、プラズマ化するけど、このプラズマの色ってのが何に
あとしますよかプラズマっぽいですね。
このプラズマの色は何で決まるの？温度白い方が熱い。私の勝手なイメージ、白い方が熱い。でも色はカラフルだよね、割と。うん。プラズマの色。ここはプラズマ。
あとしますよかプラズマの色は最終的には温度ですかね。この黄色反応より温度に依存しそう。
大気圧プラズマ。
あとダブルでケース本来プラズマによって地上との通信は途絶するんですが、スターシップは黒魔術を使っているので問題なく映像。
黒魔術ってなんで？黒魔術ってなんだろ黒魔術。背中についてる電線アンテナで通信できるからいいんですよ。背中にアンテナがあるからいいんです、背中に。
あとクオレルブルー使えば中継衛星。
この後この通りでこういう感じになって、色が途中から白から青で、これ何なんていうのかな、色変わっていく光景がいいですね。お、すごい空気受けだよな。高度は84キロ。ただいま
あとしますよかちゃったり VIEWSBYSTARLINK って入れているあたり抜かりないな。あとダブルでケイズベニーモタルトの姿。
当然ですよ。スターリンクね、実力を見せてあげなきゃ。これからの時代、宇宙でもスターリンク使えますよって。スターリンク衛星を持っていれば、宇宙でも安心して通信環境ができますよっていうアピールしなきゃね。これ、売りですね。スターリンクは宇宙でも使える。きっと、多くの宇宙機関っていうか、多分ね、通信衛星、中継衛星、いらないじゃんってなるよ、スターリンクあれば。ただいま、高度77キロ。77になります、77。スピードが落ちてますね。あれだけの質量、ブレーキにかかってるってのはすごいね。
Welcome back to Starship Flight12, the first test flight of Starship version 3. As Dan mentioned earlier, we were able to make contact with the modified satellites just shortly after deployment. And as you may have seen, we got some sweet views of those sats looking back at the ship. Pretty cool to see.
Yeah, those views were incredible.
Now, as you see on your screen, currently, the ship is re-entering the Earth's atmosphere. This is the plasma starting to build up on the exterior of the vehicle. Now, we do not plan to recover the spacecraft today, but rapid and practical reusability is the ultimate goal.
Yeah, that's right. And re-entry is a critical phase of flight, and we need information on how the ship's systems perform. Re-entry is an extremely demanding portion of flight where we essentially have to scrub all of the energy we used to launch the rocket back off in reverse. So the 18 million pounds of thrust that we had off 33 of those Raptor engines, just a little. We're now, and then another, several minute burn on the ship, we're now basically undoing all that energy here via aerodynamic braking, essentially. And of course, Starlink is a big part of it, as that's what allows us to actually gather this data and show these live views. And again, the data gathering is really the main reason why we're doing these flight tests. So Starlink provides us just one more path to collect that data that ultimately allows us to rapidly iterate Starship's design.
Now, if ship manages to make it all the way through re-entry, we'll collect valuable data on the spacecraft flying through the Earth's atmosphere at these hypersonic speeds, which is basically more than 5 times the speed of sound. Now, we do anticipate that it might be a little bit of a spicy re-entry, so we'll see how far we get. Re-entry is typically a portion of flight where we don't have communications with the spacecraft because it's re-entering at or around orbital velocity, roughly 8 kilometers per second, or for those of us that think in other units, roughly 5 miles per second. At those speeds, the spacecraft is moving through the atmosphere, and it creates that plasma field that we saw forming around the vehicle.
Yeah, and although the plasma looks really cool, it does distort some communication frequencies. So it's not uncommon to experience brief blackouts in communication. Of course, thinking long-term here, Starship is designed to land on Mars where there are no runways or other humans to help out. That's why we're going with the propulsive landing instead of a more traditional means like parachutes. Propulsive landing, not only, again, is it more cool, but it enables a more rapidly reusable rocket.
Yeah. Now we should hear some call-outs as the ship makes its way back to Earth. When we hear entry max heating and entry max Q, that means the ship has made it through the maximum heating and aerodynamic loads that it will experience as it returns. So if we make it through those, we're doing pretty well.
Yeah. And you can see in the bottom left right now, we're at 23,500 kilometers per hour speed. That's just a crazy number to think about. But as we keep progressing in the mission, we are going to hear a call out when the ship is transonic and then subsonic. So transonic refers to the period of flight where the velocities of airflow surrounding and flowing past the vehicle are concurrently below, at, and above the speed of sound, kind of in that Mach 0.8 to 1.2 range. And for reference, commercial jets have a range of cruising speeds, but mostly fly around Mach 0.74 to Mach 0.85. And after we hear the call out that Starship is transonic, we should hear the call out when Starship is subsonic. This refers to speeds that are much less than the speed of sound, so at this point in the flight, ship's velocity will be slowing down.
We definitely have a crowd still here in the lobby of SpaceX headquarters down here at Starbase, Texas. Everyone is, loves watching ship re-entry. It's always such amazing colors. This must be what it feels like to be one of those praying mantis shrimp or mantis shrimp. I can't remember exactly what the name is, but the ones that see in billions of colors. This is the closest I feel to being one of those.
Yep. I think one other thing that's cool to point out right now is looking in the bottom right, you can see where we are on a globe there. We're squarely in the Indian Ocean already, and we've only been flying for 53 minutes, so pretty crazy. We went all the way from Texas to the Indian Ocean in less than an hour.
She flies pretty fast.
She flies very fast.
機体が爆発しなかった。あとほら、燃えてない。あ、これ気になる。これ何かなってのは気になるけどさ、これが。なんだろうね、あれ。
Alright, so the light show continuing. We are through the period of peak heating, and we'll be looking at the peak pressure coming up in the next couple of minutes. The next 10 minutes are probably going to be the spiciest of entry today. As a reminder, we are going to be doing some stress work on the ship, where we're going to do a maneuver where we kind of kick the nose up to fully deploy those aft flaps to really get a good test of the structural strength of that part of the ship. We did that on one previous flight test on version 2. We're going to try and do that today. Since we did skip the in-space burn, we're carrying a little bit of extra propellant in our header tanks out in the nose, and so that's going to put a little bit of extra stress on those forward flaps as we come in. So we will see if they're able to hold through that re-entry. So that will be another watch item. We did skip that in space burn, but we are expecting at least 2 of those sea level engines to try and ignite for a landing burn. We entered the entry period in a good attitude, so hopefully making our way to the targeted splashdown point. We've got that Starship recovery team standing by. And we should be about 10 minutes away from splashdown. So a lot of excitement over the next couple of minutes. Okay, Jake, let's see how Starship holds up on the way in.
Yeah, and we just heard on the nets there that engine chill has started. So essentially what that means is we are prepping the landing engines by getting them down to temperature ahead of that landing burn later in the mission here.
And on a lot of our previous flight tests, we've been removing a bunch of the tiles. If you've watched those, we were really intentionally trying to push ship beyond its limits. On the last flight, we even had basically a hole get punched into the liquid oxygen tank that you could see when we did the landing burn into the ocean, and this ship was still able to make it. Right now, we're really going to be testing the structural strength of these flaps on the way in. Again, this is a flight test. We're trying to intentionally find where our limits are. And in this view, you're looking at a whole bunch of tiles. I think Jake talked about it earlier. We bonded some additional tiles to the leeward, or kind of the metal side of Starship, to see how those different bonding techniques would hold up. And looking like we've got quite a bit still attached.
Yeah, and as we're going down through the atmosphere here, we are at about Mach 16.1. So still extremely fast, although we have, scrubbed off a substantial amount of our speed already. Altitude at a little less than 60 kilometers.
All right, we're about 8 minutes away from our targeted landing and splashdown time. Again, this is when the ship's going to start really
Ship
getting
is approaching
the
the end of the peak heating region.
Just heard the call out, getting to the end of the peak heating, so the highest temperature the Starship's going to see during its re-entry.
Camera angle changes as it is attached to the forward flap on the Starship, so we're actually experiencing the articulation of that hardware, helping to steer the ship down for its precise landing in the Indian Ocean.
Yep, that is just a really cool, kind of cool piece of perspective there. I know some people say it makes them a little seasick, but I definitely love it. It makes it feel like you're really riding along with the ship on the way down.
Yeah, and aside from just looking cool, all these camera views providing just really critical data on how the heat shield, how the flaps themselves are holding up. That's why we've got these in the flaps and then scattered all around the ship so you can see how they hold up. There's some internal to the vehicle too, and we're getting all of this video back via Starlink, even as we're just enshrouded in plasma. We're able to kind of operate at a high enough frequency to punch through, and that is blue ocean and sunlight you're seeing just beyond the flaps. So we are coming down into daylight, hopefully splashing down in the next 6 minutes or so in the Indian Ocean. We've still got a couple maneuvers lined up where we're going to be really stressing the flaps on the ship.
The ship has passed through the peak heating region. External temperatures are coming down.
Wow, that is incredible news. As Dan mentioned, we were expecting this re-entry to be super spicy. But excellent news that we're now past that period of peak heating and that now the external temperatures are starting to decrease. Those heat shield tiles there on the belly of the ship, really doing a ton of work to burn off all of that inertia that the vehicle had prior to re-entering the atmosphere.
Yeah, and you can tell by the G meter down on the bottom right that we're starting to pick up a couple more Gs here, so we're definitely entering the thicker part of the atmosphere where we're scrubbing off all that energy, like Kate's saying.
All right, just about 5 minutes or so to go. We're coming up shortly on the maneuver where we're going to, it's affectionately called the flaps lap, where we're going to kind of pitch the nose up on the ship, and you're going to see those aft flaps, the ones in the very bottom, fully deploy.
Ship is at peak dynamic pressure.
And we're now at peak pressure.
Ship flap load test has started.
Looks like it's holding. Again, the intent of that was to put just a lot of extra stress on those aft flaps. We are expecting the forward ones too to see a little bit of extra stress as we've got a little more propellant in our header tank, so the area right at the very nose of
Ship
Starship
flap load
kind
test
of
is complete.
hammered through that test.
There we go. And we just did that test at Mach 7, just for reference there, so we are still going incredibly fast.
1時間
あと車種用とプラ力制御でやり遂げたらもう完全に脱帽ですだよ。あとダブルで警戒レベルが下がったようです。
3.5 minutes or so away from our targeted landing burn. Again, we're expecting to try and see 2 of these Raptor engines light for the landing burn. Normally we plan for 3, but we're going to give it a try with 2.
こういうほらこういうところにひびが入ってるんでこういうのが焼けて
Ship is
壊れたんでしょう
starting
ね
the RTLS banking maneuver.
ほらほらこういうとこ割れてるここも多分これも意味にが
And
入っ
that
てる
right
かな
there, so we're starting a banking
Oh,
maneuver.
hibi.
Essentially what that is when we come back to Starbase,
確か
or
に
when
再利
we
用す
plan
るよう
to
になっ
come
た
back
ら
to Starbase,
この辺
the
全部張
trajectory
り
is
替えるんだ
designed
ろ
so
うね
we'll essentially swing out over the
あれ
Gulf
してたよね
and
この辺
do
のタイルは
a
もう
swoop maneuver to then come back to the towers for catch. And
これ
so
何回も使えるように
we
見えないね
are doing that exact same maneuver
この辺
as
の
we
タイルは
head
別
towards our
に
target splashdown in the
問
Indian
題はな
Ocean.
さそうなんで
Yeah, and that call out there that we
実際
heard,
は
あと車種用回避のフィールド
stands for
隙間が大き
return
い
to
以外
launch
に熱
site.
膨張するのかな
So
あとクオレルブル
definitely
ー将
a
来の安
pretty
全
cool
のため
thing
の
we're
マイナーア
demoing
ップ
here
デー
on
ト
the
対
ship.
象
You know,
アン
as
ド
in
ブ
the
と
future,
ひ
we
び
are
割
going
れ
to be trying to
あ
bring the ship back to the launch site, which is
これ
going to be absolutely insane.
Absolutely. But of course, we want to test
こ
out
の一列に関してはもう
these
全部
maneuvers,
一列っていう
these
かここの
principles
2、3
prior
列
to
に関して
actually
は
bringing the
同
hardware
波力
back
でいい
to
ん
the
じゃないの
pad.
か
This
な
is the same reason why we were, intentionally not
どっちも
trying to
安いんでしょう
bring
ね
the booster back to the pad. So
あと
we're trying all these things
外
out
から
in this
2000 キロ
developmental
のと
phase
こ入
of
る
the
じゃなくて
vehicle,
耐熱塗装だと思います
and really
ないよ
proving what a test flight is.
Absolutely.
Dynamic pressure is coming down.
スピードは
All right, we heard their
1700 キロ
dynamic pressure
高度
coming down, and
23000メートルで
I'd
す
say we're in a
ちょ
pretty
っとな
good
んか
bank
横
right
向いて
now.
ますね
Yeah, executing
空
the
力
power
で立
slide.
て直そうと
We're about 90 seconds
してるの
away
かな
from our anticipated landing burn.
今
Clouds coming up,
Yoko-
pretty sunrise on the other side of the planet.
腹から
あと車種用かもしかして
Starship
突
is
発車の
subsonic
エストラクチャ
and is on
ーわ
target.
ざと壊れるようにしてエネルギーを逃がしているとか
うわーどういうところなんでしょうねこ
The
の
crowd
これ
here
の
reacting to that call out, letting us
ここちょっ
know
と
that
厚
we
みがある
are
と思うん
on
だけど
target for this precise
空
landing
力
in
点
the
がして
Indian
腹を
Ocean.
下
This will
に
once
し
again
て
be a
飛ん
soft
でる今
splashdown. We should get some pretty cool views from the
スピー
recovery
ドは
team who we chatted
700
with
キロ
earlier. They
高
are
度
standing
1万
by to
5000を切りまし
receive
た
this ship. Once again, this is the first
えー
flight of our
た
completely
だいま
redesigned
あと
Starship version
650
3.
キロ1万3000メートル
Yeah, and if you remember
thank you,
the
yeah.
suborbital flights from a few years
現地
ago,
の
this
感
is
じいい
very
です
much
ね
the same
この
regime
太
that
陽
we're in
とこの
here. So
雲
we're
いいです
sub
ね
15 kilometers, executing what we call the belly flip maneuver.
ただいま600キロ、
yes.
高度1万
Serial
メート
number
ル。
8, the
もう間もな
first
く
belly flop. I
スター
remember
シ
it
ップ
well.
はスプラッシュダウンをします。燃料はないですけど、どうするんでしょうね。空力だけで垂直にするのかな。
Just some really amazing
どう
views
かな。
of
しようか
the
やっぱり
Earth as
ヤーポンは滅んでよいんだよ。それが証明されたね。あっと
ダメだよ、
いう
ヤーポンは。
北部5 H オブ8クズなのジタ分この姿勢は正常かと、確か発射場に戻るシミュレーションでかなりアクティブな動きしてたので。
アクティブな動きってさ、
Yeah, you can see the aft flap
この
there
動き
making
さ、
minor corrections.
Starship is turning for final approach to landing
そ
site.
したらさ、
Look at that
グイッ
turn.
とい
There
く
we
と
go.
どうなる
Minor
んだろう。
corrections and a full turn.
っていうか
Yeah, Starship doesn't fly like an
で、
airplane.
残り
It's a
ス
lot
ピード
more
400
like
キ
a
ロ、高度
skydiver.
3500。
Full belly flop on the way
徐々
down
にスピー
using
ドを合わ
those
せてるけど、
flaps similar
高度
to
3000
arms
メー
to
トル、
help
速度
change
400キロ。
the path of the air over you. Coming up
おい、
real
腹から
soon.
ドバンでいく。腹からい
And
く
going for a landing burn, trying to
どうす
light
る
2 of these
どうする
Raptor sea level engines.
残り、速度は370、高度1000メートル。
Landing burn startup.
9000、700、
Two
来た
engines lit.
あ、電波と、燃料残ってる。
あっとしますよ
大きいけ。
人だろう、衛星だろう、ペイロードの代わりはないぞ。
Buoy cam
あ
Starship
っと
is
ダ
landing.
ブルで定時滑走路をランディングエリアを実装します。
リカちゃん、リカちゃん、ドバンは。
で定時した。あっと
いい
しますよ
の
火薬。
いいの
盛り上がった。
リカちゃん最後に大爆発。ロック完璧。完璧じゃん、今回。映像もパーフェクト。
Amazing.
ドローンの映像がないまだは。お船とドローンの映像が完璧な映像が撮られましたね。
あっとしますよ株初落ち。あっという北部5 H オブ8クズなの G を体力の浮きずだ。
To hear, but it is the truth.
でもすごい完璧だ。
Absolutely wild. We,
意外とさ、
yep, beginning of the
飛
show.
行中、もう打ち上げも不具合があったけどさ、
あっとクオレルグループで1ステージを
Guaranteed
海面
excitement
に
at
落
the
下。
beginning of the
これ
show,
が大
and
爆
I'd say Starship delivered.
USA! USA!
An incredible day for Starship. That was the first flight of that completely redesigned vehicle. As you can tell, the teams are incredibly proud of what we
エン
just
ジン
saw.
も
Yeah,
それなりに燃え
V3
焼してた
definitely
し、
showed up. That was amazing.
着陸
Yeah,
地点も
we've,
ほぼ完璧。
Pretty happy crowd in the control room behind me. I will say it's probably the most excited I've seen a lot of people in a really long time. On target landing. Wow. Actually, let's jump over. Hey Tyler, how's everyone holding up in Hawthorne?
もう打ち上げ会場だよ。
We're having a great time, Dan. Thank you so much. That was another exciting Starship flight in the books, and we hope that you enjoyed those awesome Starlink
この後
views.
パーティーです。
So congratulations to the team at Starbase
But I
and
don't
everyone
really
here and
feel
around the
so
company. So
happy
many
that's gonna-
employees have contributed to the Starship program as we continue to iterate and make progress towards a multi-planetary future. So that wraps it up for us here in Hawthorne. Thank you guys for tuning in,
うん。
and
こ
back
こ
to
ま
you,
で行け
Dan.
ばあれだね。美
All
味しいね
right,。thanks. So just to recap, we lifted off right at the top of our window, 5:30 p.m. Central Time. We were able to see the booster light 33 of those Raptor engines get off the pad and ascent over the Gulf. Successful hot stage separation. Initially lit 6 of those Raptor engines, lost one of the RVACs on the way uphill, and then the booster didn't complete its full boost pack. Its mission ended a little bit early, but landed in the clear area that we had set in advance. Once we were on orbit with ship, we were able to get through our payload deployment, 22 satellites, the 20 simulators, the 2 Dodger Dogs, which successfully turned on cameras. We'll see if we got any more views from those. So obviously stick around. Skipped the Raptor relight, but made it through re-entry on target landing in the Indian Ocean. You saw those views. Starship made it. Just it's been a long time coming. We're really excited to see this vehicle fly, and there are several more on the way. So that's going to do it for me up here. Send it back down to Kate and Jake and everybody who I hope is at least a little bit excited down in Star Factory.
Oh yeah, it is absolutely insane down here. We would, of course, want to thank the fine people of Cameron County, including the residents here at Starbase, as well as the Coast Guard, the Federal Aviation Administration, the government of Mexico, and of course the Australian Space Agency.
Yeah, so honestly, just huge congratulations to all our teammates here at SpaceX. And everyone who's supported the Starship mission just in general here. It's been a massive effort, really incredible.
Yeah, there's a lot of people that work really hard to make things look easy, so shout out to those teams. Now be sure to follow SpaceX on X for updates and more exciting views that we didn't get to show you on today's live program. I have a feeling we'll see some pretty amazing stuff come from those demonstration satellites that we were able to show some initial footage of. Now, if you're interested in more launch coverage, head on over to our profile on X. We also have SpaceX.com/launches for you to check out for the most up-to-date information. So thanks to all of you for tuning in. We're going to close it out and celebrate with our colleagues. Thank you so much for tuning in, and have a great night. We'll see you next time.
ダイジェスト映像来ましたね。ウォーター今回この映像お気に入りのようですね。わからなくもないよ。コメントはね、本当に驚きの映像。
あっとダブルでケイズ編集早い笑い。
そりゃそうでさ、スタッフの数が違うんですよ。スタッフの数が金があるんですよ、金が。あ、でもチャームさんってこれぐらいできるんじゃない？
あっとしわしわさ観客なんかよわからんが帰るかってのがいかにもアメリカ的。
まあでもそれ実際みんなそんなもんだよ。そんなもんだよ、そんなもん。これダメージにすごい明るいライト積んでたんだろうね。
あっとダブルでケースすでに1回飛ばしてたとかですかね。
どうでしょう、どうでしょう。じゃあこっからはもう一回だけ。
あとはいいぞ。 B さん T 校を思うと日本はプレゼンターいないんだろう
な。ないです。でこっからはちょっと一回その打ち上げをもう一回見ましょう。せっかくだし。せっかくなんで打ち上げる瞬間をもう一回見よう。
We're getting ready for what comes next. We're going to start pad fly.
いや
we're also building a moon base to a moment like
the boosters tracking one. They can
30 seconds.
では振り返り映像をお送りします。
Minus 10, 9, 8, 7, 6, 5, 4, 3, ignition.
あっとしわしわカジャクさんみんなにダブだし少しは見習ってもらって。
We have liftoff.
ジャックさんね。いやお金がない間に頑張ってますんで。よかったね、これは。これいつも思うんだけどさ、でもしょうがないのか。グリッドフィンは展開したままじゃないと打ち上げられないのかって思ったけど、グリッドフィンに折りたたみ機構を持たせると耐久性の問題があるのか。
All right, we are T plus 30 seconds into flight. T33 out of 33 Raptor 3 and booster V3 ascending over the Gulf now, coming up on maximum aerodynamic pressure.
Booster and ship, avionics power, telemetry nominal.
Systems looking good. We're just passing through the barrier to maximum dynamic pressure. A little over a minute into flight now. Vibrations chilling out here at Star Factory as we continue to watch Starship Flight12 arc out over the Gulf. The next major thing coming up is going to be hot staging.
Booster process
Reminder, we do what's our version of MECO. Most engines cut off, so we're going to shut down all but 5 of the Raptor engines on the booster. And then after that happens, we're going to ignite the 6 engines on the ship while it is still attached. We have clamps that hold the two together. Those are going to retract inside of that hot stage ring.
打ち上げからね、1
Kind
分
of
40
protect
秒、
them.
42、3秒でね、
Looks like we had
30キロ
one
エン
of
ジンの
the
うちの1
engines
つ
go
が停
out.
止してる。
Engines go out, still flying on 32
何があっ
of
た
the
んでしょう
Raptor
ね、エン
engines.
ジン
But
の不具合
again,
が。
once we get the hot staging, those 6 engines on the ship are going to ignite. We're going to do it in a little bit different of a sequence on version 3. Essentially, those 3 RVAC engines will ignite first. Almost immediately after, just one of those central engines is going to ignite. And that's going to give the booster a bit of a kick, sending it in a known direction, followed shortly after by the other 2.
すごいね。
We're through Miko.
Huge separation.
分離してこうさよならっていう感じがすごいよね。
There you
これ
go,
でエンジンつけ
successful
て帰ってくるんだ
hot
もんね、あれ
staging
で。
separation. We are not seeing as many booster engines ignite as we expected for boost
あ
back,
のブースタ
but we are seeing 6
ー、落下
good
したら帰
engines
ってく
lit
るんだよ
on
ね、お
ship.
家に。
It looks like we just had an early boost back
画面の
shutdown.
ここに映ってる
Again,
ん
a
だけど
reminder,
さ、
the booster was
あ
planned
と
to
高レ
essentially
ベル
head
次
into
々
the
に試験
Gulf
機を潰しながら改良
for
を
a
進めるあ
splashdown,
る意味ロケ
but
ット
it
の
has
ジャイル
shut
開発
its engines down early on into boost back.
本当はこれぐらい余力があるといいんだけどね、JAXA さんもきっと。
And we just see one of the RVAC, so we're now running on 5 engines
試
on
験機だ
ship.
って言って打ち上げてればいいんだけど、金がないからね。
We do have engine out capability, so it's going to
これ
continue
大
into
変
its
素晴らし
ascent.
いもんだったと思う。ただエンジンが壊れてるのがちょっとね、
You got
すご
booster
い
on the left
残念
there,
な点。
ship on the
で、ここからまた時間ちょっと進めて、
watch that's weak. Big,
時間をちょっと
little
ワ
and
ープワー
hot,
プワープ。
continuing to fire as well.
And it looks quite incredible.
これが残念
Absolutely.
だ
So we
ね。
have views here from the booster coming back down, making its way into
リ
the
エント
Gulf.
リーの工程の途中で、
Pretty cool to
We have
see.
healthy chamber pressures on 5
Oh,
out of 6
that's
shipwreck
not-
engines.
破壊され
Great
てし
news
まった
there
のが
for Starship.
残念。エンジンの展開に完全に失敗したんだよね。
Once again, we were not going to bring the super heavy booster back to.
これは
Once
さ、
again,
エ
great
ン
news
ジン
there
の
for
展開に失
Starship.
敗最悪に失敗したってことこれは。
Once again, we were not
十分
going
な
to
スピードは
bring
殺せないもんね。
the super heavy booster back to the tower. We were planning on having it
まあ
land
映像
in
見
the
るよ
Gulf.
り海面に落下したのがわかるけど。そしてこの辺は美しい映
Able
像を
to
送られ
stick
たもの
by
の、
waiting
Use of
as
use them for attempt to
で
Earth all
イーロン・マスク氏お気に入りのこの映像だね。今回の
In
目
this
玉は
view, you
この映
can
像。
kind of see on
あ
the
と
right
シワ
side
シ
of the
ワエンジン
satellite,
の
you
展
see
開に
some
失敗
bright
して
white
あの着
spots.
水をや
Those
り
are
遂
our
げたんだと
flashlights
それは
beneath
それ
them.
で
The
すごい
camera is going to attempt to look back and image
これからね、
Starship's heat
そ
shield
のラプター3もま
as
だ
it flies
熟成が
slowly
進んでないとい
away
うか、ま
from
だ
the vehicle.
とても伸びてるんだからね、仕方ないっちゃ仕方ないけど。いや、でもうまくやった仕方ね。この演出憎いね。演出が憎いからな、これ。そうなんだよね。
As it flies,
なん
attempt
か
to
もう
light
最初さ、太陽光が光ってるかと思ったら、この瞬間、太陽光ピカーって光ってるかと思ったら、ここにある LED が光ったんだね。これ、LED ライトですね、多分。で、これで、
In this view, you can kind of see on the right side of the satellite, you see some bright white spots.
あと
Those
ダ
are
ブル
our
で検知しれっ
flashlights
と今
beneath
後はエ
them.
ン
The
ジントラ
camera
ブ
is
ル
going
な
to
くなりそう
attempt
で
to
す
look back and image Starship's
むしろ
heat
な
shield
くさなきゃまずいんだって。
as
な
it
くさない
flies
とまずいです。な
slowly
くさな
away
いと。
from
で、
the vehicle.
この瞬間ライトが光ってつくの、こう、ライトっていうか、すげえ演出だなと思ったけど、
yeah, it
な
almost
んだ
looks
ね、
like
こ
the
れ。
light is
すげえこう、
shining right at
光の
us.
強いライト使ったんだね。
あとシワシワがめちゃくちゃ明るいライ
pretty
ト
excited.
そうそう、
あ
その通り。
とコーレルブルー新型ラプターエンジンの信頼性向上が今後の目
Always
標
sunny in space,
Come on.
and that looks like an
Sorry,
empty
Natomo.
payload bay. So
Sure does.
that's exactly what you want to see there.
エ
That's
ンジン
great.
周り。
So yeah, with payload deploy complete. Oh, You can see the door closing there. All right, there we go. So yeah, with payload deploy complete, Starship will now close its...
要改善。まあ、要改善とは言っても、あれだけのエンジンを使って、
we close the payload door, and we're going to continue to coast around Earth all the way to the Indian Ocean. So still a lot of major events to come today. Sounds like we're not going to hit that Raptor relay based on what Dan was saying, but after that, of course, we'll have the atmospheric reentry and splashdown. And with that, we're going to go on another quick coast.
So sit tight, enjoy some amazing space views and the space jams, of course. And we'll be back in a few minutes for Raptor relay, or excuse me, not for the relay, but we'll be standing by for atmospheric reentry.
Final banking turn.
師走用仮想表として断熱圏姿勢制御圏はほぼ問題なしエンジンは改良の余地ありですね
We're at these hypersonic speeds, which is basically more than 5 times the speed of sound. We do anticipate that it might be a little...
This ship was still able to make it. But right now we're really going to be testing the structural strength of these flaps on the way in. This is a flight test. We're trying to intentionally find where we're going to operate at a high-end starbase or with a couple maneuvers lined up where we're going to be really stressing the flaps on the ship.
The ship has passed through the peak heating region. External temperatures are coming down.
お金を稼がなきゃいけないからね。いつまでもロケット花火をやってるようじゃまずいんで、スターリンク衛星を乗せて、周回軌道に置いてきて、それから大気圏突入の練習をするぐらいじゃなきゃね。お金を生まなきゃね。
really doing a ton of work to burn off all of that inertia that the vehicle had prior to re-entering the atmosphere.
Yeah, and you can tell by the G meter down in the bottom right that we're starting to pick up a couple more G's here, so we're definitely entering the thicker part of the atmosphere where we're scrubbing off all that energy, like Kate's saying.
Alright, just about 5 minutes or so to go. We're coming up shortly on the maneuver where we're going to, it's affectionately called the flap slap, where we're going to kind of pitch the nose up on the ship, and you're going to see those aft flaps, the ones in the very bottom, fully deploy.
The ship is at peak dynamic pressure.
And we're now at peak pressure.
Ship flap load test has started.
師走用回路投資の窓口はこちらになりますのでじゃんじゃんどうぞ
金がねえよ金がないよ一応予定表はねまだね一応このように予定表は入ってはいるんだけど
Looks like it's holding. Again, the intent of that was to put just a lot of extra stress on those aft flaps. We are expecting the forward ones to see a little bit of extra stress as we've got a little more propellant in our header tank, so the area right at the very nose of Starship. And we're through that test.
There we go. And we just did that test at Mach 7, just for reference there, so we are still going incredibly fast.
2028にクルールナでも2028にスターシップ
Alright, we are just about 3.5 minutes or so away from our targeted landing burn. Again, we're expecting to try and see 2 of these Raptor engines light for the landing burn. Normally we plan for 3, but we're going to give it a try with 2.
現状、今後の予定は不明ですけど、多分数ヶ月以内にやってくれることを祈ります。では、お時間、最後にここだけ見てお時間とします。この着地だけもう一回見てお時間とします。
Yeah, Starship doesn't fly like an airplane. It's a lot more like a skydiver.
何回見ても
Full belly flop on the way down, using those flaps similar to arms to help change the path of the air over you. Coming up real soon. Again, going for a landing burn, trying to light 2 of these Raptor sea level engines.
すごいね。次回が楽しみなんだけど。
Landing burn startup.
エンジンもついてる。この映像すごい。ドローンの映像がすごい。
AT フィールド1枚剥がれてる。あとはいいぞ。B さん T パキスタン人の言ってた通り、溶接は荒いのがわかるの。
Buoy can't
Starship
catch
is landing.
力ないね。すごいじゃん、ほら。溶接が荒い。溶接が荒い。そんな。私、穴に溶接も飛ぶからよし。ということで、これにて私の方も本日の配信を終わりにしたいと思います。
あっとしますよかし。試験の溶接は難しいので、あっとはいいぞ。B さん T 紹介
Absolutely
員です。
wild.
はい、
The
それでは本日もこの辺で終わりにし
あ
ま
っとまず記入5946体熱タイルはテストのため、最初から1枚外してあったと
す。
思います。
そう。タイルはね、だいたい毎回1枚2枚外れてますよね。まあ、機体のね、確認もあるし、いろいろチェックすることもあるし、まあ、製品版と違っていろいろ実験器具も積んでるだろうし、まあ、その辺はね。
あっとクオレルブルー将来の有人機が着陸で万一こうなった時、中の人をどうするかは課題になるかも。
さっきの爆発の様子だけ見たらね、タンクの部分は綺麗に形残ってるけど、頭吹き飛んでるからね。頭だけ吹き飛んだからね、激しく。頭だけはね、中の人どうすんだろうね。頭分離できればいいんだけど。
あっとしますよか。あの方が実験台になるんやろうな。白目。
どうだろうね。それでは、今日はこの辺で終わりにします。本日も最後まで見ていただきありがとうございます。まだ今日という日は始まったばっかりだよね。始まったばっかりで頑張りましょう。では、お疲れ様です。
あっとしわしよかよいのが見えました。あっとはいいぞ。B さん T をはようペケペケ。あっとクオレルブルーお疲れ様でした。
お疲れ様でした。